Hello and welcome to HPL Discovery. Today, for the 1st through 4th graders, we're going to learn a little bit about heat and pressure by building our very own thermometer to learn a little bit about the science of weather. Have you ever wanted to know how hot it is outside, how cold it is, and how those compare to other temperatures? Well, scientists always want to collect data, and by building your own thermometer, we can collect data in a reliable way. Let's go ahead and gather our supplies or get them from your HPL Discovery kit, and we'll build our thermometer. So the first steps to creating your DIY thermometer are getting a clear plastic straw and a clear glass bottle. It helps to have a bottle that has a very narrow neck like this one does. But if you can't find one quite like that, don't worry about it. Glass works better than plastic because glass doesn't really expand or bend when I put pressure on it. But plastic will still work. The next step is to fill it about 3/4 of the way full using water or rubbing alcohol or a combination of the two. So let's go ahead and pour that in. Mix it with some of the water here. All right. And then we're going to color it with a little bit of food coloring. This will help us keep track of the liquid in the straw. So go ahead and we'll stir that up. And we've got a nice fine red liquid there. It's a mix of rubbing alcohol and water. Next step will be to take some air dry clay or Play-Doh, but we provide clay in the kit if you've got that. Push it into a circle. Or a flat enough piece. And then you're going to want to poke a hole through the straw, or with the straw, to see how that's kind of made a little mound around it. You're going to want to take that top piece out because you want the straw to be clear. So we're going to be putting water on it. And what you want to do is get the straw going into the water, but not touching the bottom of your glass. So go ahead and insert that. All right, I've got mine in the water. And then you want to seal it to the top so air cannot get in or escape from your glass jar. There, you see I've got that little dome sealing that on there. And hopefully that should be airtight. The idea is that we want the air inside the jar to stay inside the jar. This is going to help us measure the temperature. The next step is to drip our colored water slowly into the top of the tube. The next step is to take a mixture of the alcohol and water, or just water if you have it, and that's fine, hopefully with some color in it, and we're going to drip it into the tube. Now, if this is created correctly, it should go down the straw. We're going to start filling up the straw with the water. You can see that run down in there. Now, the pressure from the air in the jar and the water beneath the straw should allow that water to stand in there. And it looks like it did not. So you can see how it fills up but slowly lowers down, meaning that my seal on the top is not exactly perfect. So let's try sealing it a little bit better. And let's drip water in until it stays. There. Now you can see how that water is staying right there in the tube. this is going to be how we measure temperature. So right now, the current room temperature is that place on the straw where the water is stopped. If we were to change the temperature, increase heat, that would make the air molecules in there warmer, causing them to move around more. And because they cannot increase in volume, they can't go anywhere, they're going to increase in pressure. And that pressure is going to push down on the liquid and push up on our liquid in the straw. So as temperature goes up, pressure goes up, and the red liquid in the tube goes up. You may recognize this from thermometers that you've seen in your home. Now when it cools down, those air molecules are going to slow down. And when they slow down, they want to decrease in volume. And when they decrease in volume, that means the pressure is going to go down. There's not as much pressure on this water. The water on the bottom can raise up, so the water in the tube, in our straw, will fall down. So we can note the temperature dropping. That is how a thermometer works. Again, high pressure, as pressure goes up, the straw goes up. As the temperature goes down, pressure goes down, and the water in the straw goes down. Very neat little bit of science, so let's just explain the temperatures around us. Let's take a closer look. Oh right, there's one more step I forgot to mention. Because water wants to evaporate in the air, we also want to seal the top of the straw. And the way that we can do that is to use a little bit of oil. Oil is not going to evaporate into the air like water, so let's use it to seal the top of our thermometer. Because oil is less dense than water, it'll float on the top. We just need 1 or 2 drops in our straw to seal it. And what that will do is sit right on top of the water, create a little layer of oil across the top so that it doesn't evaporate out. Because if the water evaporates out, what happens to the tube level? It's going to drop. And it doesn't mean it's getting colder, that means some of the water evaporated. That's also why it's super important to have our seal on the top. It makes it so as the air tries to increase in volume, it can't. It cannot go out the sealed top, and it can't go out. It can't go out anywhere else, so it pushes up the water in the straw. In order to test our thermometer, we're going to do a little bit of man-made warming with a hairdryer here. Now, when I heat it up, the glass can expand, but the air inside will try to, and as it does that, it should push up our liquid. Let's watch. I think that tells us that it is very, very hot. Well, thanks for joining us for HPL Discovery. I hope you made a thermometer and were able to test it inside, outside, warm places, and cold places to learn about heat and pressure. One thing I'll note is that for this experiment, I did use some rubbing alcohol mixed with water, but you don't have to. You can do this entirely with water. You don't even have to color it. It makes it more dramatic when you've got color and you've got isopropyl alcohol. This has a much lower freezing point and is more reactive to temperature than regular old water. So that's why it makes for a bit of a more of a dramatic thermometer. But if you just have water, that works perfectly okay too. We'll see you next time on HPL Discovery.